Hey again. Okay, so question number 14 on the midterm study guide. Um, this is another half angle identity. This one is using cosine. So again, I gave them to you. They're up there. But the formula will be plus or minus the square root. And oh, my memory. 1 plus, right? 1 plus the cosine of theta all over 2. All right, so that is the formula for cosine. 5 pi over 12. Again, 5 pi over 12 is not on the unit circle because it is a half angle identity. I told you before, the first step for these things is to multiply your angle by 2 because this is only half. So if I want the whole thing, then I need to multiply by 2. And I don't even have to change it from radians to degrees, although we could by multiplying by 180 over pi. So if you want to do that, feel free, but again, you don't have a calculator. So if I just multiply this whole thing by 2, or like 2 over 1, right, I would get 5 pi times 2 would give me 10 pi over 12 times 1 would be a 12. Okay, and I can just reduce that fraction. I can just divide them both by 2. So that would be a 5 pi over 6. Okay, that's as much as I can reduce it. I'll look onto the unit circle up there, and 5 pi over 6 is over on the left, quadrant number 2. You see it? You see it. You might not see it on here, but you see it on your unit circles. 5 pi over 6 is on the circle, and I wanted its cosine, right? So that's its x-coordinate, and the x-coordinate at 5 pi over 6 is negative square root of 3 over 2. So this, the cosine of 5 pi over 6 is negative 1. So if it's plus a negative, we can really just write minus square root of 3 over 2. Everything else stayed the same. So far, so good? Yeah, of course it is. All right, so if you watched the last video, you would remember that when I'm trying to add fractions and I don't have a calculator, then I want to make the numerator and denominator the same as the denominator of my other fraction, which was a 2. So I'm going to change my 1 into a 2 over 2. So I have 2 over 2 minus the square root of 3 over 2. All of this is still over 2, right? And all of this is still underneath the square root. Okay? So the numerator becomes the 2 minus the square root of 3, and they're both over 2. And then I have my denominator, the blue 2, and they're all over the square root, under the square root. Okay, fractions within fractions, I'm going to multiply by the reciprocal, or I will keep the numerator. I will change the division to multiplication, and I will flip this over again by putting a 1 underneath it. So my problem becomes 2 minus the square root of 3 over 2. That was the numerator that I kept. I'm changing this to multiplication. I'm going to flip this over, right? I'll have its reciprocal. So instead of 2 over 1, it is a 1 over 2. And again, as of right now, they are all underneath the big blue square root. So what I have in there is 2 minus the square root of 3, all times 1. So it's just 2 minus the square root of 3. 2 times 2 on the bottom, that's a 4, right? And I'm going to give each one its own square root. And let's just do that now. You get a square root. You get a square root. All right, so I just took the big one and gave it both to the numerator and the denominator. That would give me the square root of 2 minus the square root of 3. All over the square root of 4 is the number 2. Again, I'm going to treat this like it was a 1/2. So I have 1/2 the square root of 2 minus the square root of 3. What I need to do now, which I forgot to talk about in the last one, was to decide this plus or minus. Was it positive or negative at the end? Because whenever I take a square root, it could be either positive or negative. That depends on what quadrant I was in. Okay, 5 pi over 6 originally was in quadrant, oh no, I don't want 5 pi over 6. Well, 5 pi over 6 was in quadrant 2, right? 5 pi over 6 was, and at this point I would just use degrees, it was 150 degrees, right? But that was after I had doubled it, which means that my original number was the 150 divided by 2. So originally, think $1.50. If I split that in half, that's 75 cents. So originally that was a 75. What quadrant is 75 degrees in? That's in quadrant 1, right? Right. All right, and in quadrant 1, both the cosine and the sine are positive. So this answer stays positive because I had asked you originally for the cosine. So again, your final answer, whether it's a positive or negative, is going to depend on where your original angle was, what quadrant it was in. Remember, we have plus, plus, this is minus, plus, minus, positive, negative. And your x-coordinate is always your cosine. Your y-coordinate is your sine. All right, I hope you get it. If not, leave a message or talk to me on Remind. Okay?